In terms of an actual solar panel, how does it work? Well, quick chemistry review here. Remember that on the left side of the chart, these are all metals. Metals are conductors. They have a positive charge. Remember ions and oxidation numbers. This is probably giving some of you flashback nightmares. On the right-hand side, you've got non-metals, and those have a negative charge. And so we know that because of the electromagnetic force, opposite and negative attract to each other. And that's what a current is. We can get those electrons to move or flow. Now, right in between, you have what are called the metalloids. The metalloids are they've got properties of both conductors and nonmetals. And one of the most important ones is silicon. So that's what's inside of most solar panels, a layer of silicon. And these are called photovoltaic cells. Photo means light. Voltaic refers to voltage or electricity. And the cell is the panel. That's what College Board's going to refer to them as, photovoltaic cells, solar power. And right in the middle is the silicon. And silicon is a semiconductor. What's neat about that is that when it heats up, as the energy hits the silicon and makes it warm, the resistance of the material drops. Resistance is used in circuits. And so the positive and negative electrons and protons are allowed to flow as the resistance in the middle decreases. Now, College Board is going to want you to know that there's two main ways that we get energy from the sun. And the one I've really been showing you so far is called active solar energy. Active means you are using a photovoltaic cell. Now, you can use it either to make electricity directly with the semiconductor, or you can use it to absorb heat and heat up water and then basically like a turbine, produce heat throughout the house. Do you guys remember the concept of cogeneration? Natural gas could be used for heat and electricity. This is the same thing. We can use it for electricity or heat or both. So solar panels can cogenerate as well. Now, the opposite or the other option is called passive solar. And this is the one humans have been using forever. We can use the natural cycle of the sun where it's high in the summertime. And so we block it so our houses stay cool. And it's cold in the winter, but the sun is low. And so we maximize how much light gets into the house, and inside convection occurs. The hot air rises and it circulates and heats up the whole room. So there's no solar panel. There's no extra technology. It's just using sunlight to heat up your house. Here's a real life example. You can see a home that gets way more light in the wintertime, and in the spring and summer, the sun rises in the sky, the trees bloom, and that shades and keeps the room cool. Why not both? Let's build an eco-efficient passive and solar home. So we've got all the windows pointing the right direction. It's built into the ground for geothermal. And then we've got the active panels on top. And the architects are getting involved. They're making buildings look attractive and unique by incorporating solar panels. China is one of the leading countries in the world on solar power, and they're building offshore solar farms. Now, remember, wind is also an incredibly old technology. We've been using it for sailing as long as we've made boats. The Dutch are famous for their windmills, which were actually used to grind grain. That's wind power. It's not what we think of as wind power because we're not using electricity. But wind power is something that humans are very familiar with. So we look at the pros and cons here, and we see that just like solar, there are no emissions. We can build them offshore, so they're out of the way, so they're not bothering people, so they're not ugly. You can use the land around them if you do put them on the land. You can farm around them. You can raise livestock. Once you build them, they take care of themselves, really. They don't need a whole lot. You can connect them all to a computer so that they automatically shut down when the winds are not the right speeds. And we can build them fast. And the price is coming way down. So the cost per kilowatt hour is very attractive right now. The bad things, well, the wind doesn't always blow. So you have to be able to have backups in place in case you're not producing enough electricity. And the biggest argument is really NIMBY, not in my backyard. All those darn windmills, they're ugly. Here you can see how we can farm around wind turbines. And this is actually good for the farmers because they lease the land. So they get a check from the energy company to put the wind turbines there. And they're still doing their normal job, farming. Here you can see solar panels intermingled with wind farms. Yeah, let's do both. Okay, so in the United States, obviously flat areas are better. Big flat areas of water, big flat areas of land, the Great Plains. You look in northern Indiana, that big wind farm that's by Lafayette. You drive to Chicago. Well, it's pretty flat there, so that makes sense. Okay, other parts where it's hilly and mountainous, and that doesn't make as much sense. So you can see the map of where we put wind power matches those flat areas. And look at this. We always think of oil in Texas, but remember last week when they lost all their power 2 weeks ago, they wanted to blame the wind farms. They said, oh, all the wind turbines froze up. And they do have a lot of them, but it still only makes up about 7-8% of their power. Bigger is better here. The longer you can make the blades, the more efficient the power generation is. Okay, so General Electric is building these massive, gigantic offshore wind turbines, 240-foot blades. One of the reasons I love hydrogen fuel cells is that the other types of energy we've really looked at, nuclear, wind, solar, hydroelectric, those all address coal and natural gas. We can replace coal and natural gas. But how do we replace oil in our cars, in our transportation sector? And in my opinion, we've seen some electric vehicles come out that are popular, but in my opinion, the future is hydrogen fuel cells. We have to use electricity to make hydrogen. So we take water and we pass electricity through it. This is called electrolysis. Probably did this in chemistry. And it separates the hydrogen gas into one side and the oxygen into the other. And so then we can take that hydrogen gas and we can put it into tanks and pumps. What's the bad thing about hydrogen fuel cells? The only true disadvantage is that it's expensive. If we invest in it, if we mass market it, prices will come down. I think we have the future right here. Through the process of basically a battery, just like a solar panel, positive, negative side, we're able to strip those electrons off. And when it comes back together with oxygen on the other side, we make water. They want you to know what goes into a fuel cell. The answer is hydrogen. What comes out? Electricity and water. Here's the basic design. You put hydrogen into the tank. The hydrogen then goes through the fuel cell. We pull off the electrons that go into the battery, and then that powers the electric motor. So it's really just an electric car, no emissions, real quiet, but it has this extra step of hydrogen and a fuel cell.